If you could open up your agenda and get O3 Energy and Roller Coaster Practice. And let's go ahead and move that over to Notability. Okay, so there's more than one way to solve for energy. In the last video, you saw an example problem of roller coaster physics in particular. These problems here, the first two anyways, are just about something like a kid sledding down a hill or a ball rolling down a hill, and using what we understand about energy to solve the problem more efficiently. So if you look at the top, we've got our regular equations here that you can use. But if we look here, this is a different way to think about it. So for this particular problem, a rock is rolling down a hill. We have a height, we have a velocity, and we want to know the velocity at the bottom of the hill. So the way we can do this is by using conservation of energy and say that the total energy at the top is equal to the total energy at the bottom. And so if we replace the total energy with the sum of the potential and the kinetic energy, we can start to have this math work to our advantage, so we're actually doing less work. The instructions are here, so you can read through that on your own, but let me just show you quickly what this is. This is saying the total energy at the top of the hill is going to equal the total energy at the bottom because energy is conserved. So that's really the whole idea behind this unit. Total energy is when you add kinetic and potential. So I've got kinetic at the top plus potential at the top. Same's true for the bottom. Kinetic at the bottom, potential at the bottom. And then what we do is we think a little bit about what is happening. And so we know that the rock has no height at the bottom of the hill. So rather than writing this here, we can just say it's 0 because there is no potential energy at the bottom of the hill. So by thinking it through, we're eliminating part of the equation already. So you have top kinetic energy, top potential energy is equal to the kinetic energy at the bottom plus 0. And so then you can just replace these with their equations and plug in the numbers from above. And then very quickly you get to where you're just all the way down to one number. So let's go ahead and try this method for this first problem here. A child is sledding down a hill and they start at the top at rest. We've been given the mass of the sledder and the velocity, and we want to know the height of the hill. So we're going to solve it all in one fell swoop. We're going to say the total energy at the top of the hill is equal to the total energy at the bottom of the hill. Okay. To find the total energy at the top, we have to take the kinetic energy plus the potential energy. Same at the bottom. Kinetic energy at the bottom plus the potential energy at the bottom. Okay, at the top, we can see we started at rest. So that means our kinetic energy at the top is 0 plus the potential energy at the top. And we know that when you are at the bottom of the hill, that the potential energy is also going to be 0 because the height is 0. So I've got my kinetic energy at the bottom plus 0. Let me write in again why this is. This is 0 because the velocity at the top is 0. And this one is 0 because the height at the bottom of the hill is 0. So that's where those two zeros came from. So now we just have our potential energy at the top is equal to the kinetic energy at the bottom. Well, that's starting to get really simple. So that's mass times gravity times height is 1/2 mass times velocity squared. Now we can even take it one step further. If I have mass equals mass, I can cancel those two things. You can plug in the 35 if you want, but it's going to cancel each other out anyways because they're on both sides of the equation. So I'm going to go ahead and just cancel those. But if you don't see it immediately, it's fine. You can still plug in the mass and the numbers will work out correctly. I'm going to go ahead and cancel those. And then I'm just left with gravity times height equals 1/2 times velocity squared. We're really getting to a very simple equation here. And we're looking to find the height. So we're going to solve for h. So I get 9.8 meters per second squared times h equals 1/2 10.5 meters per second, and then the velocity part is squared. So I'm going to divide by 9.8 on both sides. Okay, and I get h equals, so you have to do a little bit of math here, right? You're going to want to square this first and then hit enter, then multiply by half and hit enter, and then divide by 9.8. So I'm going to do that now. 10.5 squared divided by 9.8. So I get a height, of 5.62 meters. So do the algebra and see if you come up with that same height. I have loaded the key for the rest of this, so you can try the next one on your own and see if you get it. Good luck.